All right, good morning, guys. We are on lesson 5 today. More estimating probabilities. Page 37. Okay, if the weather forecast calls for a 20% chance of light rain tomorrow, would you say it is likely to rain? Well, it's a 20% chance. Okay, I'm going to say no. I do not believe it is likely. Is it possible? Yes, but I would say it is not likely. Number 2, if the probability of a tornado today is 1 out of 10, would you say that there's likely a chance of a tornado today? Again, I'm going to say no. There is a chance. It could happen, but I would say it is not likely. If the probability of snow this week is 0.85, would you say it is likely to snow? So now they listed it as a decimal. So you notice they gave it to us as a percent, a fraction, and a decimal. Okay, 3 ways to list probability. This means 85% or 85 out of 100. So I'm going to say yes on that one. It is likely. Okay, the next section we are going to make some spinners. They look like this. There are 4 of them, so I was going to put you in groups of 4 and have you spin them. I don't know if I can get all 4 of them at one time. Okay, I spun them for you, and just to prove it, here are the spinners that I used. So I just used the interactive ones, so you can certainly spin it if you want to get your own data using this. But if you want, I'll give you a little time here. Obviously I don't need to give you much time because you can just pause it. But it said spin each spinner 10 times. Okay, so I did not answer the 3 questions. That was going to be you individually. I just did all 4 spinners 10 times. So go ahead and pause it for a second and write all those numbers down. It should be 10 for each of them. Okay, so the first question after that, do you have any spinners that have the same sample space? Remember, that's all the possibilities. Okay, so let's look at the possibilities. Spinner D, the 4th one. Possibilities are 1 through 4. Spinner C, possibilities are 1 through 12. Okay, so those are not the same yet. Here's the other 2 spinners. Looks like possibilities of B are 1 through 6, even though they have some scattered around here, different numbers. We still have a possibility of 1 through 6. And here we have 1 through 6, 1 through 6. So the possibilities on this one are also 1 through 6. Okay, so which spinners have the same sample space? That would have been spinners A and B. Do they have the same probabilities for each number? Okay, so probability on spinner A of getting a 1, let's say, is 2 out of 12, or 1 out of 6. Probability of getting a 1 here is 1 out of 12. So are all the probabilities the same for each number? They are not. They are not. So I'm going to put no. Spinner 6. For each spinner, so A, B, C, D, what is the probability you'll get a 3? All right. So spinner A. What is the probability of getting a 3? Well, how many 3s do I have? 2 3s out of 12. Okay, so that's going to be 2 out of 12. And we always reduce to 1 out of 6. 1 out of 6 chances I should get a 3. Okay, B. How many 3s do we have on B? Okay, I only see 1 3. So 1 out of 12. Spinner C. Again, that's 1 out of 12. And spinner D. Now, this one is a little trickier. Okay, it's 1 out of 4 numbers, but they're not all equally spaced. Okay, and they're not all equally spaced. Okay, you might say it's a 1 out of 4 probability. Okay, but actually, if you evenly spaced it to give them all an equal chance, these would all be 1. And there's actually 6 equal spaces there. Okay, so the probability of getting a 3 is 1 out of 6. Because you got half the time you're going to get a 1, or you should get a 1. Probability of getting a 3 would be 1 out of 6 choices. Problem 7. For each number, what is the probability it lands on something other than 3? Okay, other than 3, so that means all the other numbers. Okay, so let's look at spinner A. Again, I'm going to write A, B, C, D. Okay, so how many numbers other than 3 do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 12, which is 5 out of 6. Which makes sense because I said it was a 1 out of 6 to land on 3. So 5 out of 6 to not land on 3, they should add up to 1. Because it's either going to land on 3 or not land on 3. So we can actually take all these numbers subtracted from 1. So the probability of landing on a 3 is 1 out of 12. Probability of not landing on a 3 would be 11 out of 12. Probability of landing on a 3 is 1 out of 12. Not landing on a 3 would be 11 out of 12. Probability of landing on a 3 was 1 out of 6. Probability of not landing on a 3 would be 5 out of 6. Problem 8. Noah spins spinner D, and it never landed on 1 10 times. Okay, how might that happen? So let's say you're spinning that, and it never lands on a 1. Now, is that possible? Yes. It's not very likely. So what might have been happening? You know, maybe if you had a spinner, maybe you had it slanted, so the spinner would always end up down. Okay, even when I did it, you should get it half the time. I only got 3 out of 10 to land on the 1. So I would guess if you spun it 10 times, that would be really unlikely not to get a 1. But it is possible. So maybe your paper was at a slant. Okay. Han put spinner C on the floor and spun it 10 times, so he had it flat, so there was no slope to it. He never got a 3. He said the probability must be 0, must never gonna happen. Okay, how might you explain that, why this happened? Well, remember, we're only gonna get a 3 1 out of 12 times. So that means if you spin it 12 times, you should get a 3 once in a perfect world, in theory. Experimentally, not always gonna happen. Okay, so you'd probably want to just suggest to do more trials. Okay, more trials. Are you ready? It says design a spinner that has a 2/3 probability of landing on a 3. Explain how you could precisely draw this spinner. Okay. So 2/3. So I'm guessing if I had a circle that we would need 3 spots on there. And I know that 360 of a circle divided by 3 would be 120. So you could measure to make it perfect 120 degrees. I'm just going to estimate 120 degrees. And the probability of landing on a 3 is 2/3. So I'm going to say that both of these are 3 and that this is 1. Now, again, if you want to be precisely, you need to measure that each one of these is exactly the same 120 degrees. Okay, that's what the word precisely is added there for you. Okay, last one. Teacher will give you a bag of blocks that are different colors. You do not look into the bag. Take out one or more blocks. Do not look at the bag or take out more than one block, excuse me. Repeat these steps until everyone has had 4 turns. Okay? So, I'm going to reach into this bag. And I'm going to put down what I got. Green, put it back. Not green. I'm not sure what's in this bag. Green. Green. Okay. Person 2 is going to draw. Green. 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 Okay, we're gonna do that for 4 people. Not green. 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 Not green. 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 Not green. All right, so this probability came out 75% of the time I got a green, this one 100, this one 50, this one 75% of the time. You could do fractions, 3 out of 4, 4 out of 4, 2 out of 4, 3 out of 4. What do you think is a probability of taking a green block from this bag? So based on our experiment, what do you think the probability of getting a green is? Okay, well, it seemed like 75% was the middle, the median. It's definitely not 100%, and it looks like it's going to be more than half of them are green based on these 2 results. So maybe 75% would be a good guess. How could you get a better estimate without opening the bag? Okay, you can always do more trials to give you a better estimate. Okay, more trials. Just to show you what was in the bag. Okay, 2, 4, 6, 7. Green, 2, 4, 6, no. 9 out of 12. 9 out of 12 were green, so it's actually 9 out of 12 reduces to 3/4, which is 75%. So our experiment there went really well. Okay, it went, in theory, what you were expecting. Okay, good summary on the bottom of page 40. Your assignment is page 41 and 42. 5 questions today. All right, hopefully you guys are continuing to stay safe and healthy, and I hope to see you again in person soon. Bye-bye.